So today we're going to continue chapter 1. We've got a couple sections left here. We're going to be solving inequalities, which is an Algebra 1-ish concept, as we've said before. We're going to solve one-step inequalities, and multi-step inequalities. And the only kind of new piece is this set builder notation, but you can see what that looks like. In a normal problem, we would have come down and we would have probably been doing some work. We would have got x is greater than 9. That's what we would have gotten. Set builder notation takes that, adds a couple of little cute pieces to it, but it's really the same, right? You see that it's still the same. Set builder notation, this is a set symbol, so it's the set of all x's such that x is greater than 9. But being able to make that connection is very simplistic. You should not have any problem with that if you see it somewhere along the way. As a brief review, we're going to talk about graphing these two inequalities. First of all, x is greater than 4. Very typical, very normal thing. So 4 is the important number. It's not that I don't care about the 1, 2, 3 or the 0 or the 7, 8, 9, 10, but 4 is the important number. And for us then, in graphing this, we know at 4, where x cannot be equal to 4. There's no equal there. So there's no filled in dot. It's open. Okay? But then we have x is greater than 4, and so those are these folks here that we're going to shade to the right of 4. For the second one, x is less than 4. Again, we have a 4 here somewhere, and we cannot be equal to 4, but we can be less than 4. And the beauty of this, if you haven't already observed it, is the inequality symbol kind of points the way that the colored arrow points when we do the graph. The inequality symbol points to the left, so our arrow goes to the left. And that's when we have inequalities written in this form. X, blah, 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 whatever. Okay? Now, here is with an equal, which is absolutely no more difficult than the one we just did. Our important number is -3. We could talk about -4, -5, -6, or -2, -1, 0. We could talk about those, but the important thing is the -3. And we know that it could be equal, so our dot gets filled in, and then we shade the direction of the arrow. Similarly, for the x is less than or equal to -3, and -3 is our important number, could be equal, because we do have the equal, and then our shading goes off to the left, because x is less than or equal to a -3. And then we have this, which looks a lot like the first couple that we did, but there is a little piece here that I want to make sure we get. So our important numbers are 6 in both cases. And when we graph not equal, shade to the right. And when we graph not equal, shade to the right. You see it? You see the problem, see the issue, see the thing? Because the arrow's pointing that way, but I shaded to the right. Why? Because that's not written like the other 5. It's that little game we played in first grade. One of these things is not like the others. All the others were written with the x on the left. Let me show it to you real quick. X on the left, x on the left. So the shading went with the direction of the inequality symbol. Same. Here, though, we don't have x on the left, and so that simplistic piece is gone. And that's one of the reasons we talk about pattern. We talked about pattern last year, patterns in our Alg 1 class. Because it's when we deviate from the pattern that things become difficult. You get used to doing things a certain way. You have a certain pattern. A baseball player walks up to the batter's box and he does all the same thing. He twitches and he fixes and he does because he has a memorized pattern of what he's going to do and how he's going to do it. And so I used to coach track, and a kid would go out and they're going to do their triple jump, and they would have their thing that they were going to do, and they would rock 3 times, or they would do whatever because they had a routine. It was a developed, memorized routine, a pattern. So I can't emphasize that enough for us in math class. Now, if you look at this, this says 6 is less than x, and it is. These are all the x's, and 6 is less than that. So you can see it, you can graph it that way. It's not illegal. It's not illegal. It's just more reasonable, I think, to recognize that you got x and 6, little m pointing at the 6, and that's just so much easier to graph. It's really the same thing as that one up there. So just be aware of that. It's not wrong to have the x on the right side. I just like it to be consistent for myself and for my students, because I've seen them, fall apart right there and crash and burn, and that's unfortunate. And so a more important thing here, I guess, as we plow our way through this, is to look at this inequality that has not already been solved. But these are super simple to solve. In fact, solving inequalities is just as easy as solving equations, except for one thing. One thing, and maybe you remember it. One thing. Otherwise, those properties of equalities apply to the properties of inequalities. And you can add, subtract, multiply, and divide on both sides, except for one thing. We'll look at that in a second. So here, we would want the x by itself, get rid of the 3, so we subtract 3 from both sides, and we have this. So here's our important number. We are not filled in, and we're shaded off in the left direction. Very easy. Very easy stuff. Stuff, no problem. Same thing here. We have 3x is greater than -12. So we want to get the x by itself, get rid of the multiplication 3. How? You divide both sides by 3, and so x is greater than -4. So -4 is our important number. It's not equal, and shade in the right direction. X is greater than -4. And so as I mentioned, those properties of equality and properties of inequality, we can add and subtract both sides, no problem. If A is greater than B, and you can add both sides, if A is less than B, you can add both sides. Same thing can be said about subtraction. No problem. We still maintain the same inequality. So that's very easy as the one we just did. Here is then a problem where we have some options. First of all, we have some options. I'm going to tell you what I would teach an Algebra 1 student or a pre-algebra student and apply it here. First of all, we have options. As I said, I'm just going to put a little mark down the board, and we're going to do it both ways just to look at it. If I was doing this problem myself, I would probably take the 5y plus 2 and the 4y minus 3 with the little m pointing at the 4y minus 2. I'd probably reverse it. Why would I reverse it? Because not only do I like the letter on the left, I like the larger letter on the left. And when you look at this, the 4y and the 5y is larger. Do you have to do it? No, I've got room over here to do it the other way. Do you have to do it? No, but I like it that way, and I think it works better that way, and it maintains that pattern, and it's just something about routine that is very helpful here. So once I've done that, then I bring the 4y over here, and I take the 2 over there, and that's what I get. Very easy, very easy. Then I could graph it, and it says to do that. But looking at this the way that it's written, I'm just going to copy it here, the way it's written, and I'm going to say, all right, I'm not doing it that way, which is my preferred way. I'm going to go ahead and do this. I'm going to take the 4y over there and make it y, and I'm going to take the -2 over there, make it -5. Hopefully you know that -3 minus 2, and I get that. But what's wrong with that? What's wrong with that? Prior to that, what's wrong with that? Well, it's written backwards. So I can still write it correctly now, right? Little m pointing at the -5, I still get the same answer. It works. It's just that I did it to begin with. Other people would do it at the end. Now there is one additional way to do this, a third way that we don't have room to do right in here. There is a third way, and that would have been to not solve for the y on the right side, but solve for y on the left side. But we're going to save that for a few minutes later. But you can see the answer that we got is correct. And then, of course, graphing it, whatever, and open and all that's great. So this one would solve pretty easy because the larger letter is already on the left, right? The 6x is bigger than the 5x. So I'm just copying here. Take the 5x over. Bring the 2 over, it's an add 2. And so you can see x is greater than 9. And so it can't be that because we don't have the equal. Same thing here, don't have the equal, and it's shaded in the right direction. But anyway, which one is it? It's that one. It's the A answer because it's not equal and it's stuff that's less than, so it's shaded to the left. So A is the answer. And this is where the weird part is, if you remember this from your Algebra 1 class. So I said, you know, solving inequalities just like solving equations, except for one thing, and this is that one thing. And that is, if you're multiplying and dividing by a positive, no problem, no big deal, it's simple. But if you multiply and divide by a negative, you have to flip the inequality symbol. If it was greater than, then it has to become less than. If it was already less than, then it has to become greater than. And of course the equal would apply there as well. And we see the same thing down here with division. If you multiply and divide by a negative number, it flips the symbol. Okay? That's just that one thing. And I can tell you as a teacher, I have made that mistake on doing answer keys a lot because you get busy doing other things. You know, you're worried about all these other details and you forget that one thing. And so I can be sympathetic to, look, the letter's not on the left. I'm not doing that like that. You can if you want to. But the first thing I'm going to do is I'm going to take the 0.3p and I'm going to take the 12 with the little n pointing at the 0.3p. Little n, right? Pointing at the 0.3p negative. And then I'm going to say, well, if I want to get p by itself, I've got to divide both sides by a negative 0.3. So I've got the negative 0.3p divided by a negative 0.3, and I got the 12 divided by the negative 0.3. But because I divided by a negative, I have to flip the sign. And of course, when I do that, these cancel, leave me with a p. And these are going to give me a negative number, and 12 divided by 0.3 is going to be some big number like 40, I think. Let me see if that's right. Yes. So it says p is greater than or equal to negative 40, and that's what I got. P is greater than or equal to negative 40. And then once I know that, then the graph is pretty easy. Because 40 is my important number, negative 40 is my important number. And you can see they did put that in set builder notation, but you know, it's the same thing we got, just with the set notation. That's the only difference there. So this one, I don't have to turn anything around because it's already with the letter on the left. But if I'm going to divide both sides by negative 3, and that's what I would want to do, get rid of the multiplication of negative 3 by division by negative 3. Then I've got to flip that symbol. And that's just, you got to remember to do it. You just got to discipline yourself to do it. So x is greater than or equal to 21 divided by a negative 3 is a negative 7. So you've got, all of these have the dot filled in, so that's good because that works. But then which one has the less than 7? Negative 7. That would be the B. Set builder notation. You can see what we got, you can see what they got, and you can see how that works. I will say don't trust them, though. Don't just look at the inequality, look at the graph, or don't just look at the graph, look at the inequality, because they could mix them up. They have been known to do ugly things to us before. So carrying on, we can run into some strange things, different things like, So look at this, and let me just copy it over here. Look at this. So it's an inequality and it's got fractions in it. So what did we say to do in the previous lesson when we had an equation with fractions? Remember, we make the fractions disappear. And how do we make the fractions disappear? By multiplying by the least common denominator. Yes, the least common denominator. Here the only denominator is 2. So I'm going to multiply by 2. Multiply by 2. these twos cancel and leaves me with a negative 2x is greater than x minus 7. So I said that one problem we did earlier had a third way to do it. So this is kind of that third way. It's a little different numbers, but still. So I'm going to take the x over, and it makes it a negative 3x is greater than a negative 7. And then I'm going to have to divide both sides by a negative 3. So negative 3x divided by negative 3 and negative 7 divided by negative 3. But I've got to flip that symbol. And that would then imply that x is greater or less than 7/3. Now I'm going to go ahead and graph that while we're here because I want to do that. So there's 7/3. Somebody's like, oh, I don't know where that is on the number line. Well, I won't say I don't care because I do, but 7/3 is just a little bit bigger than 2, but it's not quite as big as 9/3, which is 3. So that's where it is. Like that's where it is on the number line. And then that's open on the negative, on the positive 7/3, it's open on the 7/3, and then I shade in the left hand direction. Let's see how that lines up with what's in the answer key. Less than 7/3, right? That's what we got. Yep, less than 7/3. And they wrote it in set builder notation, and there's their picture, and you can see we're close to 2, but we're closer to 2 than we are to 3, and that works. So after that, you know, pretty much the rest of this is just doing the nuances of each particular problem. Negative 2x is greater than x plus 5 times 3. So how are we going to get this inequality with fractions taken care of? We're going to multiply both sides by the least common denominator, which is 3. And so that's going to be a negative 6x. It's greater than, and the 3's cancel here, so I have x plus 5. So throw that over, I get a negative 7x. And then I divide both sides by negative 7. Which makes me have to change my sign, so x is less than negative 5/7. And that says that. And it's graphed correctly because you got the negative 5/7 shaded in the left hand direction. So B is our answer. We would probably never do a problem like this in real life, but they're trying to get used to applying these things to real life problems so that should you encounter something where you have to do it maybe a little dicier than this in some other coursework you may do, you'll have some clue. Javier has at most $15 to spend today. That's what he's got, at most $15. What's that mean, at most $15? I mean, think about it in just logical stuff, at most $15. That means he can spend $15 or less. Do you agree that Javier, I'm just going to put a J, Javier's money is going to be less than, or his spending can be less than or equal to 15? Just as a concept, do you agree that's how that would work? Okay. So he's got less, he got $15, it says at most 15, so he's got 15, but he can spend less. So he buys a bag of pretzels and a bottle of juice for $1.59. Gas at the store costs $2.89 per gallon. How many gallons of gasoline to the nearest tenth of a gallon can Javier buy for his car? Okay. So reading that a couple times or 3 times or whatever it takes to sort of process it, Javier stops. He's got his $15 in his pocket. He stops and he wants pretzels and juice. He just really does. And it's $1.59 for the pretzels and juice. And so he knows that he can buy gas, but he can't buy too much gas because he's got to be able to buy his pretzels and juice because Javier wants his pretzels and his juice. And he looks at the price per gallon, and it's $2.89. And he's like, okay, so how many gallons can I buy? Remember the question, the great question. What don't we know? We don't know how many gallons. So let's let G equal the number of gallons that Javier can buy. okay? So now we're gonna write an inequality, normally an equation of inequality. Does it make sense that the money he spends I'm just writing this as a concept, money he spends is at most $15. Okay, it's like, yeah, that's what they're saying, money he spends is at most $15, okay? So how much money does he spend? Well, he spends that, food money and gas money. And that has to be less than or equal to $15, right? I'm just, you see how I'm sort of taking my time getting there, because that's what you need to do, instead of freaking out and trying to see the answer in one moment, an instant of time, because it usually just doesn't work that way. It just doesn't work that way. So here's the deal. So we know what the food costs, $1.59. That's what it costs for his pretzels and the bottle of juice. We know what the gas costs. Somebody's like, oh no we don't. Yeah we do, it's $2.89 per gallon. So $2.89 per gallon. And how many gallons is he gonna buy? G is the number of gallons, and that's less than or equal to 15. And that, in blue, is the mechanism we're going to use to solve this question. Now, I realize you might would have done it another way, but like I said, we're learning how to apply these things to the real world. So we're going to have to move this and move this so we get the G by itself, because that's what we want to know is the number of gallons to the nearest 10. So I'm going to move this and move this. I move that one first. I hope you know that. I deal with that before I deal with that because it's closer to the G. So I'm going to subtract the $1.59. So I have the $2.89. And I'm going to subtract the $1.59. So that's going to be $13.41 is what that's going to be. $13.41. Then I'm looking on here because I'm going to hurry up, little thing. I'm going to do that math with my calculator. So I'm going to divide both sides by 289. It's a positive 289, so I don't flip the symbol, right? Only when I divide or multiply by a negative, and I'm not. So I'm not even going to write it. But I'm going to do the $13.41 divided by the $2.89. And I'm going to write this so that we see it, 4.640138. That's the answer that I got just now when I did that. So when I did that, I get gallons is less than or equal to 4.64 and so on. So how many gallons of gas can he buy to the nearest 10th? Well, he could buy 6.40138, but to the nearest 10th, he can only buy 4.6. Let me warn you of something. You cannot round up on this problem. We wouldn't anyway, because the 5 or the 4 is not 5 or above, so we wouldn't anyway. But you can't round up because that would put him over the pennies for his $15 purchase. So 4.6, that's the answer. 4.6 gallons, that's the answer to this question. So they kind of went through that process of understanding just like we did. You'll be able to see this in the Google Classroom. They talked about the food, the gas. They wrote this thing up. They got the same 1341 that had to divide by the 289. They got 4.6. So Javier can buy up to 4.6 gallons of gas to the nearest 10th. He can't buy 4.7. He just can't. Doesn't have enough money. Unless he's got some change hiding in his drawer, and that was not what we were told. Okay. So this problem is going to be much the same, work the same, and now you can go try it.